For this problem, I'll start by identifying my m and n terms. An exact differential equation should be in the form m dx plus n dy equal to 0. The coefficient for dx is 5x plus 4y, so we know m is going to be equal to 5x plus 4y. The coefficient for dy is 4x minus 8y cubed, so we know that's going to be our n term. We can now take the partial derivative of m with respect to y. Nothing happens to this 5x term, and we can differentiate this 4y term. It'll just be 4. We can now take the partial derivative of n with respect to x. This negative 8 times y cubed term will be 0, and 4x will just be 4. Because these two are the same, we know this equation is going to be exact. We can now take the integral of m with respect to x. So we'll take the integral of 5x plus 4y dx. This will be 5 halves x squared plus 4xy plus g of y. This will be equal to f. The partial derivative of f with respect to y is definitionally equal to n. We can also take the partial derivative of this term up here with respect to y, and that'll be equal to n. So we'll take the partial derivative with respect to y of 5 halves x squared plus 4xy plus g of y. We'll get that n is equal to this 5 halves x squared term will be 0. This 4xy term will just be 4x, and g of y will be g prime of y. We said n is equal to 4x minus 8y cubed, so I'll write that here. That'll be equal to 4x plus g prime of y. These 4x terms will cancel. We'll get that g prime of y is equal to negative 8y cubed. We can take the integral of both of these sides with respect to y. We'll get that g of y is equal to negative 8 times 1/4 y to the 4. So g of y is equal to negative 2 y to the 4. We can plug that up here for this f term. So f will be equal to 5 halves x squared plus 4xy minus 2y to the 4. This will all be equal to c. So our final answer will be 5 halves x squared plus 4xy minus 2y to the 4 is equal to c. If this video helped you, consider subscribing.